Hello everyone, welcome to this discussion about how you can build AI products using a code recommendation engine that we have developed at Feedback First. The code recommendations engine name is Gideon, and we're going to see how Gideon has been helping us and will help us build AI products. So what is the problem? Why exactly do we need Gideon? Why do we need a code recommendation engine to build an AI product? Let us say you are a product manager and you want to build AI products and you're not great at coding. You know some basics of coding, Python probably, but you are not really a coding ninja to get started and build something as advanced as an AI product. So where do you start? Right? That's exactly where Gideon comes to your rescue. It's a code recommendation engine that helps you with popular ML coding patterns. So all you need to do is, just like how you guys have perfected Google search, you need to be clear about what exactly is the task that you want to accomplish, and Gideon will take care of everything else. Let us see Gideon in action so that you get a sense of what exactly Gideon can do and it cannot do. Let us say we want to build an image detection engine, right? We want to upload an image and you want the objects in the image to be identified and output should be returned to you. Okay. Now let us see how that can be done, right, using Gideon. So first, this is the Gideon code recommendation engine. So it is hosted here, aiquotient.app is the URL. Once you register, you get access to the code recommendation engine, right? And now here I'm going to put in my task, right? So detect objects in an image. Okay. Once I do this, once I type this search query, I get a lot of responses. But the first response is what I'm interested in: detect objects in image using Google's Vision API, right? And here I also get other options: detecting text in a PDF and a host of other coding recommendations engines recommendations. But usually, you also have object detection in a video stream performed using Olo, right? And then you also have other techniques also present here. Okay, so now first things first, what I'm going to do is I'm going to look at this coding pattern, and this sounds interesting, Google Cloud Vision. So let me just copy paste this content here. Okay, and then build the object detection engine. So let me just copy paste first the library part of it. Right, so let me just copy paste this aspect here. Okay, and I come to my file here and I come here, put in this, right? And one thing that I need to be careful is whatever the Google, because I'm going to use Google Vision API, I need to first enable the Vision API. And I also need to make sure that the service account credentials are stored and this file is present in my folder. Right? And let us say that has been taken care. Now I'm going to execute it. These packages are going to be now loaded. Right? In the meanwhile, I'll come here and then I'll have a look at this function. So basically this function is talking about figuring out what the objects are in the image, localized objects in the image using Google Cloud Storage, right? And one thing that is interesting here is, in order for me to use this, I need to upload the file to Google Cloud Storage. Whatever is the image that I'm trying to upload, so that image has to be uploaded to Google Cloud Storage, and I need to get that URL, right? So that is something that I need to keep in mind. Okay, and the first thing, let me just copy paste this content. Right, so it also gives me a sample example of how this particular function can be returned. Okay, let me just put a function here. Okay, and this code looks good. I'm going to first initiate the vision client, and then I'm going to run this object localization method in that vision package, right? And I'm going to print the number of objects found, and it is also going to give me the confidence with which an object is found. It's also going to give me in that image the point coordinates of the different areas in the image which map to objects, and it is also going to finally return to me an object list. So this is what is this particular method doing. Okay, now this function is present. Now the last step is to upload an image, right? And then run that URL. So for now, let me upload an image. Okay, so let me come to the Google Cloud Storage, my Google Cloud Storage account, and I'm going to this bucket, fan drive. And here I'm going to upload a file, right? What file should I upload? Okay, so let me just come here and then come to pictures. right? And then probably let me look at some picture that I can upload and get some interesting insight from it, right? So probably I'll just look at a food picture. Okay, let me just upload a food picture here. So this looks good. This particular Greek momos food, right? Let us say we upload this. We have apples and we have momos. Let us see if this can be actually recognized by Gideon. Okay, so let me just come here. I'll upload a file. Click on upload a file. And it is going to now ask me to upload, select the file location. And I'm looking for Greek. Oh, okay. Let me just upload the file again. I'm going to look for Greek momos. Let me get it. Yep, here we go. That's the Greek momos file has been uploaded. So if I just come down, okay, let me just see where that is located. Yeah, here it is. Right, so I click on this image and I get the Google Cloud GS util, right, Google Cloud Storage URL. So I copied this to the clipboard and I copy pasted here. Right, now I just execute this. And it is going to take time. It has found 3 objects. Nice. It has found apple. It also has found food, and it found 2 apples basically. It found 2 apples, and the Momo part, because it is Google's Vision API, probably it was not trained on momos, particularly Greek momos, right? But at least it has told you that it is a food. It was able to identify that food aspect of it. Right? Now you can build a simple app around this, right? So you can actually build a front end where you upload the image, right? And you can even, Gideon will also help you to figure out how do you upload this image to Google Cloud. Right now I have done it manually for the sake of demo, but you can also programmatically do that. Let's say, for example, upload a file to Google Cloud Storage. If you want to look at the coding pattern for that, you just click on this particular search query, right? And then once you do that, you'll see that this is a coding pattern. This is how you can actually do it and programming wise do it, right? So you can give the local path for this source file name, right? Make sure that the function is being, the notebook in which this particular function is being called is located in the same folder as the image. And then you run this code and automatically it will be uploaded. And then once you upload, you get the output from this. And based on this output, you can do a whole lot of things. You can actually show the exact vertices in which in the image itself where the objects are located, right? Or probably you can put some business logic around this, saying that the moment you find apple in an image, maybe you want to show recommended fruits, right? When somebody orders this, right? Somebody's interested in this, you can show recommended fruits to that person. Okay, the possibilities are endless, but the whole point is you are able to build this AI product end to end from this particular perspective. Okay, so this is how you are going to use Gideon as a code recommendation engine, right? And why the confidence is different for 2 apples, right? As you can see here, for 1 apple, the confidence is 0.88, and for the other apple, it is 0.64. Right? So why is the confidence different? Right? Let us also look at the image part. The reason why the confidence is different is because one of these apples based on the texture aspect of it, right? So based on texture and the positioning part, and also the angle in which the photo is done, right? So if you see, I think the confidence is high for this apple compared to this apple. That's basically purely because of the texture and also the dimensions in which it is seeing this, right? Compared to the other one left. Even though both of them are arranged side by side, I think the distance and also the positioning of the apple, the texture part of it, is slight change in texture. You can notice that, right? This is slight orangish red, and this is slight dark red, right? So that's the confidence is taking a hit on that. I mean, even Google's Vision API has a lot to improve from that direction, right? So this is how you can build a image detector, and you can also build something similar with respect to, let us say, if this is one example, that what if you want to detect text in a PDF? This is detecting images in a PNG file. What if I want to detect text in a PDF, extract text from PDF, right? So again, you come to the engine here, right? So I want to detect text in a PDF. Okay, you just put in that coding pattern here, right? And then here you're going to see results. right? And you can see again, you can use OCR, optical character recognition from Google's Cloud Vision API. Right? So probably you can again call this function here, which is going to help you asynchronously detect image, text, content, right, inside a image. So you can also use this particular coding pattern. Again, you copy paste it into the Jupyter notebook, and then you run the URL, right? So it is going to return a dictionary text output, right? So where you're going to just give the cloud storage URL for your text. Let us say I'm going to extract text from a brochure. I upload the brochure to the Google Cloud Storage bucket, give the URL, and this is the URL of the new file in which the output has to be kept. So typically what happens is this Cloud Vision API is going to break the output into JSON files. And let me also show how that works. Right? If I just come here, you upload the brochure into this file, and then the output is going to be, as you can see, is in JSON file format, right? And what you have to do is this particular coding pattern, it takes output from all the JSON files and it combines that into a text output, right? So this is how typically it works. Okay, so this is how you actually build AI products. Basically, just like how there are only 3 types of data, if you look at it, right? You have typical structured data, numerical data, you have text, you have images, and you have audio and video, right? And in the case of Gideon, right, you're going to analyze text, you're going to analyze images, you're going to analyze video and audio, right? You can build a video search engine. So if you guys remember, previous discussions we have learned about how do you build a video search engine. How it was built on Phantom Drive is actually by using the coding patterns provided here. At this point of time, there is manual decision making, meaning Gideon will recommend your coding patterns, but it is you who actually selects it. But in the future, we're also looking at how can we simplify that application of coding pattern so that even though you're selecting, no need to Control-C, Control-V this. Right? Can you probably simplify it to such a certain extent that you choose and you automatically apply this on the data set itself, rather than copy pasting it and making changes to the input parameters. So that's the future for this coding recommendation engine. If any of you are interested, do let us know and we'll add you to the project as collaborators, right? And what else can be done with this code recommendation engine, right? So let me also show you other use cases that we have achieved, we have accomplished in the last 1 year. Right, so let me just do this part here. Let us say we want to perform customer segmentation for this. Right? As you can see, the demo for the customer segmentation part is going to be something like this, where you want to perform customer segmentation on visitors to a shopping mall. Right? Where do you start? Right. Again, Gideon is going to come into the rescue. First step is you load the data first, right? And in order for you to load the data, you'll be checking for customer segmentation coding patterns. So you just type for customer segmentation using probably k-means clustering. You are more aware of k-means clustering, right? Let us say you have k-means clustering, and then you have customer segmentation for different techniques also come in picture, and you have coding pattern that not only uses clustering, k-means clustering, it also uses Plotly for visualization purposes, right? So I'm going to copy paste this. I'm going to now change the name of the data set here. Instead of read_CSV, I'm going to say mall_customers because that's my data set. It's in my location, right? And then the moment I do that, I'm going to run head so that you see the output. Now I'm going to copy that part of the coding pattern, which lets me build k-means, because the whole purpose here is not to be lost in the details of coding, because that's what prevents many people from implementing their ideas quickly. Because we know k-means clustering, in order for you to build a k-means cluster, you need to use scikit-learn package, and there is a specific way to do that. Right? If you want to improve that algorithm, it's a different story altogether. But if you want to use the basic scikit-learn algorithm, you don't want to spend time Googling, researching, finding out what syntax is it and all that. Right? So you take the pattern, and then you quickly are able to change the parts of that pattern to suit your requirements. Like say, for example, the column names and everything. And once you are done with that, you just run it and you'll be able to get the output. As you can see, we have placeholders. Gideon says placeholders, column 1, column 2, column 3. You replace that with the actual column names. And then you run it and you can see the elbow method, right? Optimal number of clusters, like what is optimal number of clusters that we should be focusing on. And then once you do that, now the next step is to visualize the clusters. You said 3. Is I think 5 is the optimal number of clusters. That's where you're seeing the elbow. Right? Now you can copy the remaining part of the coding pattern and then actually visualize the clusters. That's all these 5 clusters, how the data set is going to look like. Again, you need to change the column names. This is what we're trying to automate. But the idea is simple, so that you as a human has control over what can be done and what cannot be done using this. Right? So these are now the clusters have been identified for all the different data points. And now the next step is to visualize it using the scatter plot in Plotly package. So we're going to do this. And you also can do this with PCA. There's also a coding pattern where you get to do k-means clustering after doing PCA. So here again, I'm changing the cluster, the column names, right? I'm going to type in the column names here, age, annual salary, annual income, right? And then I'm going to see how all the data points are actually mentioned here, right? So I'm going to now look at the spending score, right? As you can see, it is, imagine you building this from scratch, writing all the code and everything from scratch. It will take time, isn't it? And the amount of time, as a data scientist, you should be spending more time analyzing the results, not in coding, right? So you making sure that data is making sense, you are able to come up with some interesting insights from the data. That is more important for you, right? And that's exactly how the coding recommendation engine works. Right? And this is not the end of it. We have close to 100 coding patterns, and more coding patterns are being added as we speak. It is also going to be an open source project pretty soon. So we're going to actually open it up for people to contribute. And the idea is the more data that is going to be contributed, the better are the chances that the engine is going to learn from it, right? And right now, this is one example of AI product, which is audiobook, PDF extraction and content. There are hundreds of AI products that you can try out. If you go to the same website, you have, if you go back to the home, right? You also have close to 40 to 60 product ideas outlined here. If I just come here, right? These are the different AI products that you can build using Gideon. Right? So these are some of the predictive modeling ideas: food recipe recommender, stock predictor, activity tracker, job recommendation engines. Right? These are all some of those products that you can build directly using Gideon. Right? You also have computer vision ideas. So where you're looking at CV related stuff, fake image detector, highlight generator, food contamination analyzer, text to image generator, CCTV analyzer, crop monitoring, right? Smart glass, image restoration, magical cropping. So here, if you click on learn more, you'll be getting the directions, right? So as to like how can you build your own Google Glass for $100 time. And Gideon will help you with all the coding muscle that you require to build these products. That's exactly how we are looking at implementing this. And anybody who is part of the Feedback First program, they will be having first-hand access to the premium features of this code recommendation engine, along with the help of a mentor, so that you can actually customize it to suit your needs. Okay, cool. So with that, we conclude this discussion, right? So you can have a look at Gideon at aiquestion.app. You can also, if you want more personalized mentoring to build products like this, because this code recommendation engine was built by our students. If you want to build something like this, and if you're interested in learning AI from scratch, do visit our website, feedbackfirst.app. And you can also go to YouTube to find out all the previous recordings and some of those other discussions that we've been having for the last couple of years. Thanks for joining.